So the SI unit of dipole momentum is coulomb meter. Dipole momentum is equal to coulomb meter, nothing but Q into 2A. Now we are going to write down the dimensional formula or dimensions of the P. Dimensions of P is equal to Q, nothing but IT into, what is this 2A? Distance, nothing but the length. Therefore, dimensions of P is equal to what is this I? Current. What is the dimensional symbol of the current? Ampere, capital A. T, time, length. Therefore, L power 1, T power 1, A power 1. This is the dimensions of P or dimensional formula or dimensional symbol of dipole momentum. These brackets which represents the dimensional status of a physical quantity. Length power 1, time power 1, A power 1, where A is equal to ampere, nothing but the SI unit of current, where Q is equal to IT. From this one we are deriving like this. Now we are going to discuss one sample problem on the concept of dipole momentum. The problem is like this. If an electron in ground state of hydrogen atom, H atom means hydrogen atom, is assumed in rest, then find the dipole momentum of electron-proton system of hydrogen atom in Dipole. Listen carefully. Actually, Dipole discovered the electric dipole and he is asking the dipole momentum in Dipole. We know that dipole momentum unit is coulomb meter, but 1 Dipole is equal to 1 by 3 into 10 to the power of minus 29 coulomb meter. Now we will find the answer in coulomb meter, then multiply with this one, then the answer will convert into Dipole system. So listen carefully. What is dipole momentum? P is equal to Q into 2A. What is this Q? Charge. See the question, electron in ground state of hydrogen atom. That means what is the charge of electron? E2A or 2A. P is equal to Q into 2A. Q is equal to E because charge of electron into 2A, nothing but the 2AE. Therefore, dipole momentum P is equal to E is equal to charge of electron 1.6 into 10 to the power of minus 19 coulomb into 2A is the distance between or the separation between two opposite charges. Here he is asking electron-proton system. The orbit radius of hydrogen atom is 0.53 angstroms. Therefore, 0.53 into 10 to the power of minus 10 meters. See, 1.6 into 0.53 into 10 to the power of minus 19 into 10 to the power of minus 10, it is 10 to the power of minus 29 coulomb meter. 1.6 into 0.53, it is how much? 0.848. The answer we got in coulomb meters, but see the question, we should find out in Dipole. Therefore, dipole moment in Dipole is equal to 1 Dipole is equal to how much? 1 by 3 into 10 to the power of minus 29 coulomb meters. What is the answer in coulomb meter? 0.848 into 10 to the power of minus 29. 0.848 into 10 to the power of minus 29 by 3. 0.848 by 3 is equal to 2.544. because it is already 10 to the power of minus 29 cm is there, coulometer is there. Therefore 0.848 by 3 is equal to 2.544 dB. This is the dipole moment in dB. This is in dB systems, this is in SI system. Electric dipole means two equal and opposite charges are separated by a finite distance, and we discussed about the dipole momentum and its related units and dimensional formula also. Now we are going to discuss about the applications of the electric dipole. Whenever an electric dipole is placed in electric field, how it will behave, and what is the electric field intensity along the axial line and equatorial plane. These three are the related problems to electric dipole. Now we are going to discuss about the couple of force acting on dipole when it is placed in uniform electric field. Initially, this is the structure of the electric dipole. This electric dipole structure is placed in uniform electric field. These are the electric field lines which always emanates to forward direction. As we discussed already, electric field lines starts from positive charge and terminates at a negative charge. Like that, this is the electric field lines, minus Q and plus Q. The force is a force of attraction, and one more thing, the force acting on the positive charge is plus QE. Here it is minus QE. This is the original setup of the dipole which is placed in the uniform electric field. Couple acting on dipole when it is placed in uniform electric field. This point we should discuss. Couple acting on dipole when it is placed in uniform electric field. Because of the force of repulsion, this positive charge experiences the force of repulsion and it goes up. Then the diagram will convert like this. This arrow marks represents the uniform electric field. Here it is the negative charge, experiences the minus QA force. Then the positive charge will shift to upward perpendicularly, and this is the initial position of the positive charge. Means from this position to this position, here to here, the positive charge was shifted. Now just please draw the line which joins the center of two charges. The distance between these two charges is 2a. Now, because of the force of repulsion experienced by the positive charge, from this position to like this, the dipole was changed. Now, the distance is 2a, we know that. Let us give the names of the positions A, B. A, B, C. Now, please listen. This dipole was obliquely changed its position whenever it is placed in the uniform electric field due to the force of repulsion. Now, what is sine theta from this triangle ABC? Opposite side by hypotenuse. What is opposite side? BC. What is hypotenuse? AB. So BC is equal to AB sine theta. What is this AB, sir? 2A. Therefore BC is equal to 2A sine theta. Why we are calculating the BC? This BC is nothing but the perpendicular displacement due to the couple of force. Now we are going to discuss about the couple acting on dipole. Means couple nothing but torque experienced by the dipole. Now couple means torque experienced by the dipole. Couple is equal to torque What is the definition of torque? Force into perpendicular displacement. The symbol of torque is like this, tau. What is the force experienced by each and individual charge in the dipole? QE. Into. What is the perpendicular displacement? Initially, this is the position of the dipole. Now it is displaced like this. From here to here, the positive charge was changed. So this BC gives the perpendicular displacement of the dipole. What is BC? We already discussed, 2a sine theta. Now, I can write like this, Q into 2a sine theta into E. See, this Q into 2a is nothing but the dipole moment. P E sine theta is equal to tau. In vector form, tau is equal to P bar cross E bar. So this is the expression. What is this expression? Tau is equal to P E sine theta. In vector form, we are writing tau is equal to P bar cross E bar. This is the couple acting on dipole when it is placed in uniform electric field like this. Now we are going to discuss a small problem which relates to this situation.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.